Year 9, this video is about a bit of a review about the idea of volume and moving towards finding the volume of right prisms. So first of all, what is volume? We've no doubt heard this before in our previous classes. What is volume? Volume is the amount of three-dimensional space within a closed solid object, and we can break that down into a simple model here as a start. And if each of these little squares, for example, have another dimension which goes across, so we have 1, 2, 3 dimensions. This particular square would be 1 times 1 times 1. 1 times 1 times 1 is 1 cubed, or just 1. That'd be 1 cubic centimetre. We could break down any larger object into units, cubic units, and this one would be here 4 across, 3 wide, and up by 1. That'd be 4 by 3 by 1. 4 by 3 by 1. That'd be 12 centimeters cubed, and basically we multiply the three dimensions together. If it's a cube shape, if it's got multiple cubes, we add those individuals together, and thus we've seen what you would have seen in year 7 and 8. So volume is an extra dimension on top of area, I suppose, and we're talking about an amount of space inside a solid body. And we need to look at conversions just as we did with length and we did with area. Back on the video where we looked at the difference between the units of area, it's not as simple as linear units or length units. We know that we have three dimensions here. So if we have length, width, and depth, 3 units, 3 dimensions. It's a bit rough. And if each one of these is, say, 1 centimetre, we have 1 centimetre times 1 centimetre times 1 centimetre, as we just mentioned above, and that's 1 centimetre cubed. However, if we use millimetres to use a different unit, that'd be 10 times 10 millimetres times 10 millimetres in the height. That would be 10 times 10 times 10. 10 times 10 times 10 is 1,000 millimetres cubed. So there's a difference of 1,000, a factor of 1,000 we should say, when we're looking at a certain volume, the same volume in centimetres cubed compared to millimetres cubed. So that would be this conversion here. If we have a certain unit in centimetres cubed, we need to multiply it by 1,000. And 1,000 is written here in this way. You might recall from your previous work, 10 cubed. The main thing is to remember that you multiply by 1,000 when going from centimetres cubed to millimetres cubed, and we divide by 1,000. It's a similar process to linear and area units. However, we have different numbers for the reasons that are similar to the area. We have more than one dimension. In this case we have 3. So centimetres and cubic metres, we have 1,000,000. So it's 100 cubed. It's 100 times 100 times 100, and that is 1,000,000. So it's quite different, isn't it? The magnitude of the numbers, or the size of the numbers, is quite different. And we have 1 billion here for the same reason. I don't think I'm going to fit that in, but you get the idea. You can see 1 billions over here. Okay, so to go from kilometres cubed to metres cubed, we multiply by 1 billion. Metres cubed to centimetres cubed, we multiply by 1,000,000, and then it's 1,000 from centimetres cubed to millimetres cubed. It's the same amounts, but it's division going from the smaller units to the larger units, because we would expect a smaller number if the unit is larger when the volume is the same. To use an example, if we had to convert 458 millimeters cubed into the same volume but with centimeters cubed, which is this example here, we're remembering that we're going to get a smaller number for our answer, aren't we? We recall that going from millimeters to centimeters cubed is a smaller number because we have here a case where we have to divide by 10, divide by 10, divide by 10 for each dimension, because there's 10 millimeters in 1 centimeter. So again, we would expect a smaller number. That's why we divide, because the same volume will need far fewer cubic centimeters than it will need cubic millimeters. So we're looking at 10 by 10 by 10, or 10 cubed. You're welcome to write that in as 1,000. You don't have to write it like this necessarily. They're both the same, of course, and we have 458 divided by 1,000, and that will move the decimal point, if you like, or move the number to the right, and the decimal point will stay where it is. We get a number 0.458. So it's the same volume, but it's with different units. That's a conversion. In the final part of this video, we're going to look at this idea of capacity. It's very closely linked to the idea of volume, very similar idea. We tend to use capacity when we're talking about fluids. We can use volume for the fluids as well, but capacity tends to be used mainly with fluids. And fluids are things that flow, things that collapse under their own weight. When we're looking at, obviously an example is water, but it can be gases as well, liquids, gases mainly. Even bitumen that they use on the roads has been shown through a very long experiment to flow, and you could use the units for capacity for it. If you buy a can of drink, or orange juice or something, or a soft drink, you'll notice that it won't say centimeters cubed or anything on the side. It'll say milliliters or liters. So this is where these ideas are used. We've got some common ones here. Megaliters, mega meaning a million. Remember, there's a big M for mega. Kiloliters, small k. L's always a large symbol. That's 1,000 liters. Megaliters, 1,000 kiloliters, which is 1,000 times 1,000. That's a million. That'll be 1 million liters. Mega meaning a million. 1 million liters. Litre, as you probably know from your previous studies, is 1,000 milliliters, and milliliter is 1,000th of. Notice how it's 1,000th of a litre. Notice how it's got a small m there. So we need to remember these conversions here that I just mentioned. In fact, all of those 4 points in the conversions I just underlined are important. We need to get an idea of the link between this and volume. So we have 1 litre is 1,000 cubic centimetres. It could be represented by a cube. It doesn't have to be a cube shape. A cube is a simple model, so I'm going to show you using a cube. A cube, it's a very rough cube, Mr. Herbert. Looks like someone sat on this cube and it's gotten distorted, so please trust me that it's a cube. Slightly better. You'll need to forgive me for that untidiness there, but you get the idea. That is 10 centimeters times 10 centimeters high, 10 centimeters across, 10 times 10 times 10. 10 times 10 times 10 is 1,000 cubic centimeters is the volume. Now that is also equivalent to 1 litre. It has a capacity of 1 litre, so 1 litre of water would fit in there. 1 litre of gas. So another common one is a cubic metre. That's a larger container, and it's 1,000 of these will fit into 1 cubic metre. Why is it 1,000? Well, to turn this into 1 cubic metre, we would need 10 times as much length, 10 times as much width, and 10 times as much height in a cube. Because you might remember that 1 metre in each direction is 10 times 10, 100 centimeters. So that's why times 10 times 10 times 10 is 1,000. So have a cubic meter equals 1,000 liters.